Okay, hello. In this session, we are going to look at projects as complex activity networks, and we learn how to calculate such networks. So we learn how to calculate the shortest duration of the project. We also learn how to identify critical activities, which are activities that cannot be delayed at all. Otherwise, the whole project will be delayed. And also, we learn how to calculate float for those non-critical activities. And that is useful to understand how much we can shift different activities in different places, for example, due to resource constraints, so that they can be done and completed without delaying the whole project. So, I start here by giving you the kind of a activity notation, a kind of an activity node, and how we mark the different durations and early and late starts and late finishes for those activities. And I soon draw it on the flipboard. But I still want to kind of motivate you by saying that according to our project definition, the project is defined as a unique entity formed of complex and interrelated activities, having a predefined goal that must be completed in a specific time within budget and according to specification. So now we are in this session focusing on the project as an entity of complex and interrelated activities. Okay. Well, we use the following kind of a notation for an activity. Activity is marked on a node. And we have here the activity name, and then we have duration. For example, duration in minutes, in days, in weeks, or so. Then we have here the early start and early finish. And then we have this activities late start and late finish. And we mark also the dependencies between the activities with arrows. So this activity can be a predecessor of the successor activity. And of course, there can be other predecessors that precede this activity, which must be completed before this activity can start. Okay, now in this following picture here, we have a kind of a work breakdown structure of a house painting or wall painting project. So in this picture, we can see that we are going to paint the living room and bedroom walls. And also, when you look at these activities that we have marked here, we can see that we also, at the same time, because we have to take all the furniture away during the painting, so we also are going to polish the floors and we are going to wash the windows. Those are part of this project. And in this work breakdown structure, we have also marked the durations of each activity in this structure. Now we have formed activity network from these lowest level work breakdown structure activities. And you can see that there are 3 activities with no predecessors. So remove the furniture, put paint in spray gun. We use the spray gun. We have only one of them when spraying the living room walls and then the bedroom walls. Then we get the window washing equipment. Those activities don't have any predecessors. But then the arrows mark the dependencies to successor activities, and we also have the final activity there in this logical relationship describing network, where we store the equipment and leftover paint. It takes for a while, 45 minutes is the duration. So this is the kind of a logic that we start calculating here. And as you can see, the very first activities that don't have predecessors, they have the early start or earliest start of 0. So we are in the time point 0 here. Then we calculate the early schedule. And we do it by taking the early start, then adding the duration, for example, the remove furniture activity, 0 plus 15, then we get the earliest finish of that same activity, which is 15 minutes. And then when we get into a situation where we have several predecessors, we take the successor activities earliest start, which is the biggest figure of the predecessor's earliest finishes, because of course all predecessor activities need to be finished before any of the successor activities can start. For example, the polish floors activity, we have the early start of 15, which comes from this remove furniture early finish. And in this way, we calculate the network with a kind of a forward pass calculation, and we get with the final activities early finish 165 minutes. So this is the shortest activity that this project can take. Then what do we do next? We move the last activity's earliest finish to latest finish, because we also want that our project will be end at the latest at the time point 165. And then we start calculating backward, the network backwards. We do a kind of a late schedule calculation for the network. So we subtract from the last activity 165, the duration 45, and we get actually the latest start of the last activity, which is 120, and so on. And when we have now several successors and we move towards their predecessors, now we select the smallest figure from the succeeding activities' latest starts, because when this successor activity needs to be started at the latest, the earlier it must be started, then it requires that all predecessor activities must be completed at the latest by that point of time. So we choose the smallest figure in the backward pass calculation when we calculate this network. And in this way, we have managed to calculate the early schedule and the late schedule, forward pass and backward pass calculation of the network. Okay, now we have the point of time where each activity can be completed. And when looking actually at those activities, we can find out which are the critical activities in this network, which form the critical chain, or critical path, sorry. And those critical activities are those that don't have float at all. And we calculate the float by subtracting from latest finish the earliest finish, or alternatively, we subtract from latest start the earliest start. For example, if we take from this picture below the wash windows activity, so we have there the latest finish 90 and latest start 60, and we have the earliest start 5 and earliest finish 35. And we have a float of 55. 90 minus 35 or 60 minus 5. Which means that we can start this activity at the earliest, at the point of time 5. But we must also start that activity at the latest, at the point of time 60. So we have a float, which is a kind of allowance for us where we can start those activities, or we can execute those activities at different points of time. And this is really useful when we, for example, have some resource constraints. We can shift the places where these non-critical activities are conducted without delaying the whole project. So now we have calculated the network, and we are ready to move those activities in the time axis. And in this picture, the activities are in the time axis, and also the critical activities are marked in this picture with the red color, and the non-critical activities are with blank bars. But also the floats are marked with tails after those non-critical activities, which indicate how we can shift the actual place of the activity, for example, due to resource constraints. And in this particular case, we have started all the activities in their earliest possible start. Okay, then if we continue a little bit by looking at how we can then look at the resourcing that this project requires. We have there in this picture two kinds of resources. We have a wife and we have a husband. And with this resource diagram, which is marked on the time axis below this Gantt chart, we can see that in some parts of the project we need two husbands and two wives. So of course we can borrow the husband from the neighbor, but that also is possible to kind of level those activities and shift them according to the floats, so that the shifting of those non-critical activities don't actually delay the project, but that levels the resources that it might be possible maybe to manage the project with one wife and one husband. As an additional thing, I want to show this picture when we now finalized the calculation of the networks to a kind of Gantt chart presentation. This Gantt chart is very useful also in following project progress by adding this kind of a broken line to the Gantt chart. Here we have the time now, which is 30 minutes. So the project has progressed 30 minutes. And we can see from this picture that some activities like polishing floors, which are ahead of time, and then some activities are a little bit like the get window washing equipment, which are non-critical activities and which are now scheduled at the very earliest start, earliest possible start in this particular Gantt chart. So to sum up, we learned in this session how to calculate activity networks. We learned how to calculate the shortest duration of the project. Also, how to identify the critical activities which cannot be delayed or otherwise the whole project will be delayed, and also how to calculate the floats of non-critical activities that allow us to position the activities at different points of time, for example, due to resource constraints. Do you have any questions? Okay, we continue in the next session. Thank you very much for being here with me.